Carbon from Print TM. Carbon from Print Ltd is a company dedicated to in building top-tier and mid-market companies, including CMS, to track and reduce carbon emissions, where they have comprehensive analyze and reduce. In this calculator, different have a different categories. These categories has houses, flighting, car, motorcycle, bus, and secondary. Uh, in each category, fill in data as they were present and how the presentation is seen as a result they have my signature of carbon. Regarding the results, my signature is 1.39. Compared to those of Colombia, it's 1.76. It's lower.
MIHUELLA calculator. Created by a Chilean company, this calculator uses the parameters set by the Greenhouse Gas Protocol, or GHG, which is a standard designed to provide a framework for businesses, governments, and other entities to measure and report their greenhouse gas emissions in ways that support their mission and goals. Within the calculation, it is considering the electricity consumption at home, energy consuming transportation, that will involve mean of transportation, car size, time of using per day or per year, consumption habits, waste management, and recycling. In this case, the calculation was made considering that live 3 people at home in order to calculate the individual carbon footprint. Firstly, it is calculated the energy at home, where we ask the following questions. It is how much do you spend on electricity per month, and how much do you spend on natural gas. In those cases, well, the value needs to be entered using Chilean pesos, but well, in that case, it's important to remark that the value entered for bills is an average of energy and natural gas consumption, which was converted to the equivalent amount to Chilean pesos. I mean, from Colombian pesos to Chilean pesos. Besides, it is asked me about number of liquefied gas bottles per month, as well as the type of heating that I used, either electric or combustion. But in my case, I don't use this type of energy, so I didn't enter anything on those questions. Then it is determining the carbon footprint for energy in transport using the following questions. So the question is, which type of automobile do you have, and how do you use it in the city? In that case, I use a small car. That in this case, this calculator consider that type, like a car with a cylinder capacity of up to 1,200 cc. I drive this car like 10 hours per week to go to my work mainly. So in that case, it's important to remark that for the obtention of that kilogram CO2 per hour factor was considered an average velocity of 40 kilometers per hour in this case. This calculator asks as well like how many trips I do on using a plane or the transportation with public transportation. In this case, I didn't use plane trips over the last year. And normally I need to go to 18 translation stations per day, so I mean it's 9 each way. And this calculator asks if I make like long trips out of the city on car, so which type of automobile I use and how many kilometers in total per year, and how many people I do those trips. In that case, I use like a medium car size that is considered here like with a cylinder capacity of up to 2,000 cc. And like a simple calculation here, I consider that I travel like around of 950 kilometers per year with 4 people. Okay, after that, it is calculated the carbon footprint for our consumption habits and waste, asking the following questions. It's asking like the diet, like which products I consume normally on a week. I put like the respective values there that I consume per week, and well, it's mainly with meat consumption. And well, on the other hand, as for the vegetal products, so how many and which of them I consume normally on a week. I put the respective values there, and well, with that, as well, like the waste management, the consumption habits and waste management, like of the following waste, which of one like I consume plastic or glass. In that case, I used to use 3 plastic bottles per week of 500 cc. After that, as for like my water consumption per month, this case is like 14 cubic meters. And well, in that case, recycling, I only consider glass recycling in some cases. And after that, well, appears like the results of the after that appears the result of the calculation. So well, according to all this information, the result is totalized within each type of consumption waste, and the sum is the individual carbon footprint generated per year. Well, getting the following. So the energy at home is 40.1 tons of CO2 per year. The energy in transport is 2.52 tons of CO2 per year. And well, the habits, the consumption habits and waste is 0.98 tons of CO2 per year. The sum of that, it is 3.92 tons of CO2 per year. So with that result, it can be observed that my carbon footprint is like much lower than the average of the Chilean population, which generates 5.7 tons of CO2 per year.
For the carbon footprint calculator from France, set by the Wuppertal Institute for Climate, Environment and Energy with the help of Henkel, a German company, the parameter sets for the calculation are home, with the items of living space, electricity, heating, kitchen, laundry, and bathroom. The other item is food, with diet, drinks, and eating out. The other one, mobility, with cars and other ways of transportation. The other one, vacations and leisure, with holiday, sports, textiles, and entertainment. And for last, sociodemographic data. The Wuppertal Institute is a research institution of sustainable development and is doing research with institutions like the Center for Environment and Energy Research and Studies and some universities, and is member of ECORNET, the Ecological Research Network, between others. The next step of the calculation is the parameters of home. So we have living space, electricity, and laundry. So in my example, living space is 220 square meters, and there is 3 people living in the house. For electricity consumption is 2,784 kilowatts per year, and the laundry is done at home 2 times per month in a temperature of 20 Celsius degrees. We dry our clothes 2 times per month with a drying rack. For the parameters of heating, kitchen, and bathroom, we wash our dishes by hand 21 times per week. We heat our house and hot water with electricity, but we don't heat our house, so but you have to put it. So I shower for 15 minutes with warm water. I don't take baths. I don't use hair dryer. I use a manual toothbrush with cold water, and I do not leave running the tap water when I'm brushing my teeth. So these are the parameters for this slide. For the food parameters, we have diet, drinks, and eating out. The parameters ask how many cups of certain drinks you had. So I have 2 of coffee, 3 of water, and 1 of milk per day. Another parameter was how many times per week you eat meat. So I eat 3 times per week. And the last parameter was how many times you eat food that was not prepared at your house. So in my case, 1 time per week. For the mobility parameters, we have cars and other ways of transportation. These parameters do not count the holidays and business trips. So one of the questions is what type of car you own. So I own a conventional car, medium size, that uses petrol, has a fuel consumption of 6.4 liters per 100 kilometers. I drive it 30 kilometers per day, and 3 days of the week I drive it, usually alone. From the other parameter, we are asked what other modes of transportation I usually use, and I use the bus, approximately 30 kilometers per day on 3 days per week. For the sociodemography data, they ask personal questions. I believe this is more for statistics rather than the calculation of the carbon footprint, but they were necessary. They ask for the gender, age, level of education, household income, and how satisfied are you with your life. For the vacations and leisure parameters, we have holiday, sports, textiles, and entertainment. The parameters are the use of online streaming services for videos, in my case 3 hours per week, and online streaming services for music, in my case again 7 hours per week. For the textiles, the other parameter is how often you buy clothes. I buy less than 1 piece a month. For sports, I play indoor sports 1 hour a week. And for holidays, I didn't have a holiday in the last year, so these questions don't apply, but they basically were what mode of transportation did you use on vacation, and what was your type of hotel vacationing. And my results were that my annual carbon footprint is 3.2 tons of CO2 per year, is below the global average, that is 5 tons of CO2 per year, and is also below the average of the French, that is 5 tons of CO2 per year, but is above the global target, that is 2 tons of CO2 per year. I think this was a very good tool because it asked a lot of questions, so I think I got a very good calculation of my carbon footprint.
Broad for Thy Well is part of the evangelical work for diaconia and development. EWDE for short is a development agency of Protestant Church in Germany and is globally active in more than 90 countries around the world. The organization is a member of various national networks and international organizations and works closely with other 8 organizations. Its objectives are to strengthen the poor, promote peace, and preserve creations. This organization has a carbon footprint calculator which is divided into 4 categories: nutrition, living place, mobility, and consumption. The calculation procedure starts with its first category, nutrition. It has 6 questions. First, how often do you eat meat and sausage? Often, I eat meat and sausage every day. 2. How often do you eat fish? Rarely. I eat fish once a week. 3. How often do you consume other animal products? I often eat animal products every day. 4. How often do you buy organic food? Often. I buy all the staples like potatoes, bread, cereals, oil, and vegetables. 5. How often do you buy seasonal products in your region? Often, I buy some products that are not in the season on a regular basis. 6. Do you throw away the food? I throw the food very rarely. The next category is living place. 7. What area do you live in? I live in an apartment and it has around 14 square meters. 8. How hot does it get? I answer 18 because it has an other answer, other option, and in my apartment we haven't a heater, so I mark 18. The next category is mobility. 9. How many kilometers does he travel with the following means of transport? I travel 0 kilometers by bus and train because I don't use the train and rarely use the bus. I travel around 1000 kilometers by a car per year, and by airplane I travel around 2000 kilometers because I travel to Cucuta to Bogota 2 times by year. The next category is about consumption. 10. How big is your personal fleet? I have 0 bicycles, 0 motorcycles, and 0 cars. 11. How complex is its installation? I have the usual things, but I do it without a dryer, for example. 12. How much money do you spend on other consumer goods per month, like clothes, entertainment, restaurant? I spend around 50 euros, like 200,000 Colombian pesos. 13. How much trash and waste paper do you generate per week? I generate 1 sack of garbage per week, and used paper almost none. I do not receive newspaper or magazine. I do not print anything, and I rarely receive anything packaged. Results. My results show that my carbon footprint is 3.7 global hectares. If all people had this carbon footprint, it will take 2.3 planets for it. Analyzing my results, my carbon footprint is below that of an average person in Germany. My highest contribution to the footprint is nutrition. This is because I consume meat every day. A factor to take into account is the base quantity added together. This amount adds 0.9 global hectares, 25% of the total amount, the second highest, to my carbon footprint. But this amount represents the infrastructure in Germany, like hospital and roads, and by not residing in this country, my footprint will be lower.
The World Wide Fund is the largest conservation organization in the world with more than 5 million members worldwide. Is present in more than 100 countries and carries out around 1,300 projects for the protection and the environment. Basically, the WWF is one of Australia's most trusted non-governmental conservation organization, taking the challenge of climate change and building a world where people live in harmony with nature. The World Wide Fund's calculator bases its calculation on the following categories: food, housing, and transportation. In the first category, the type of diet is asked about the consumption of meats, vegetables, and products of animal origin. In the second, the calculator asks to record the percent of processed food that you consume. In this case, 15%. The last category is the transportation. This is as the type of vehicle that is normally used and the vehicle kilometers driving in them. The second question of the category is the amount of kilometers traveled by public transportation weekly. And to finish the calculation, they are asked for the flight hours per year. In the housing category, the first question that appears is regarding the type of home you have. In this case, it is a house with running water. The next question is about the type of material with which the house is built. For the calculation, brick, concrete was answered. The third question was the number of people living in the house and the size of the household were entered. The last question in the housing category were regarding the level of energy efficiency consumed at the home, the percent of renewable energy that is used and the amount of waste that is generated compared to the neighbors. The results obtained are divided into two parts. The first shows the day when our time limit on Earth exceeds and the number of planet Earth that will be needed to support the people who inhabit the planet with the lifestyle record on the calculator. The second part shows the percentage of consumption according to land type and consumption category. In addition to giving a global result for the ecological footprint in a global hectares, the carbon footprint in tons per year, and the percentage of carbon footprint. As can be seen, according to the consumption category, the percentage contribution in the carbon footprint by food is 35%, shelter is 33%, goods and service are 15%, and mobility is 2%. A carbon footprint of 9.2 tons per year, which in the percentage is equal to 52%. The high consumption of meat, the indifferent use of plastic products, the lack of awareness regarding individual energy consumption, the daily use of high pollution cars are routine acts that affect the environment and increase the carbon footprint that we print in the world. As seen in the table of Rivera, in Colombian agriculture, including meat production, contributes to 0.37% of the ecological footprint in the world. Of that percent, 35.9% correspond to energy, 33.9% to agriculture, 5.2% to waste, and 20% to land use and forestry. Finally, within the possibility to reduce the environmental impact, the following is proposed. First, disconnect the cell phone charger when it is not in use, because if it is left connected, it continues to consume energy. Other is reduce the use of plastic if there is an eco-friendly option. More should be considered, for example, reusable bags and thermos, solid shampoo, glass toppers, metal straws, among others. The third is the start practicing active mobility, traveling bike or walking to help reduce footprint and maintain the health. Reducing the intake of meat is perhaps one of the most significant changes in the day-to-day, but considering the benefits, it is believed to be very prudent. The final is consider the 4 R's: reducing waste whenever possible, reuse such waste if there is a possibility, recycle and recover materials. With these changes in lifestyles, a 35% reduction of the carbon footprint as seen in the table.
For the water are energy reduction proposals. For the calculator, of Henkel, the carbon footprint calculator, we propose to replace the use of the household car with a bicycle. So as stated before in the calculus of the carbon footprint, I use a household car, but also the public bus. So in this current proposal is only going to be for the household car. So from the page fuel economy, from the EPA, we got the data of how many CO2 the tailpipe produce from the car per mile. So with this information and the information from the carbon footprint calculator, we add the total kilometers per week, which is 90, and multiply it by the number of weeks per year, and then divide the results by the equivalent of 1 mile to 1 kilometer to turn the results into miles per year. Then the miles per year are multiplied by 404 grams of CO2 per mile and divided into 1 million to obtain the tons of CO2 per year that the car produces. And when we subtract this from the annual carbon footprint, we got a reduction of 36.8%, which is a lot. So we think it's a good energy reduction proposal, and it's very feasible.
Well, according to Asoplásticos, in Colombia, 1,252 million kilowatts per hour were consumed on 2016, where to produce a 1 liter PET barrel, approximately is 1.1 kilowatts per hour is required. So in this way, this type of proposals allow a better use of these barrels, avoiding a greater amount of garbage and allowing the decomposition of the material. And with that, it can be reduced between 20 or to 40%, depending on the impact of this alternative would have on the waste management applied.
Vehicle, the low emission is 0.55 liters for kilometers. The motorcycle, the low emission is 84% more efficient for the combustions.
Solar panels calculation. According to what was said in class, it is for me to show the calculation of solar panels. Considering this model and assuming the project settlement will be on Bogota, it can be observed that it has a commercial power between 300 and 335 watts, but taking into account that the maximum value would be on ideal conditions, in this case was selected the last one, that is 300 watts, due to the weather changes in Bogota's particularities. So with that, some initial data were established and calculated to proceed to make the estimates for the calculation of solar panels. The first is the median radiation that was calculated as the simple average, the annual simple average of the global horizontal radiation, or the annual average sun hours in Bogota. So the consumption per household is taken from EPM data, and with that value can be calculated the annual consumption per household. Later, it is possible to make the calculation for obtention of power solar panels. In this example, was considered a single building with 20 apartments and will be installed 40 units of solar panels. So it is required to determine which is the building consumption and the power generated in the building with that renewable energy. So well, in this case, we apply the formulas. So you can see that formula to obtain the variables. In this case, the P means power, and the C consumption. So in this case, the power per panel was median radiation multiplied by the commercial power on kilowatts. So in that case, the result is 1.74 kilowatts per hour per day. The power of the building is the power per panel multiplied by the panel units. In that case will be 25,349.25 kilowatts per hour per year. And the consumption, the building consumption, is the consumption per house, per apartment, multiplied by the number of apartments. In that case, we consider like a overconsumption of around 30% for common areas and high transit zones of the building. So next it is shown like the table with the summary of the results in that case. And well, we can see that the building consumption is greater than the power generated. So in that case, that means that edification needs to supply the demand, use the power of the conventional energy. In this way, it is going to be calculated to the substitution percentage. So in this case, it is calculated as the division of the power of the building by over the consumption of the building. So in that case, the result is 53%. Therefore, in that case, the conventional supply is around that value, in which if it is added some losses in the system, that may indicate the building is able to supply around half of the energy demand by people, allowing the system not to be more saturated and reducing the CO2 emissions.